Okay, the other kinematics quantity is speed. Speed is defined as distance over time. For example, you are familiar with miles per hour, kilometers per hour. Miles is a distance, the hour is a time, that's a speed. Speed is what you read off the speedometer. What you read off the speedometer is what we call instantaneous speed. Instantaneous. That's the speed at that instant. Sometimes we deal with instantaneous speed, sometimes we deal with average speeds. It is expressed in meters per second, that's the International System of Units, and then common day use here in the US, miles per hour, kilometers per hour if you travel to Europe, and then other units, sometimes feet per second, etc. Okay, direction is not important since it is a scalar and it is always positive. Speed is always positive. Okay, as an example, what is the average speed of a racehorse that runs 1500 meters in 2 minutes? Okay, in this particular case, the horse ran 1500 meters. The speed is distance over time. So in this particular case is 1500 meters over 2 minutes, which is going to be 750 meters per minute. Now, of course, if we needed to express this in other units, we can do now the unit conversion. Since here they didn't ask us about other units, we are going to keep it as this. Like when we talked about distance, we said we don't really use it much in physics because it does not have the full information. It does not have the direction associated with it. The same is going to apply to speed. We are going to use speed in some quantities, and you'll see that later on. And actually distance even. In some quantities we use distance as well, but not in the study of motion. In the study of motion, neither speed nor distance is useful enough. Now, instead of speed, we are going to deal with velocity. We define velocity as displacement over time. Displacement over time. The unit for the magnitude of velocity, the magnitude of velocity is a speed, its units is meters per second, the SI units, or miles per hour, or whatever. Now, again, magnitude of a velocity, it is a speed. So its units are meters per second, miles per hour, or whatever. However, velocity is a vector, where direction is important. When you get, God forbids, if you get stopped by a highway patrolman, they don't really give you a speeding ticket. They give you a velocity ticket. Because when they give you the ticket, they give you the speed and the direction. So direction, even in tickets, they don't call it the right name, but even in traffic tickets, it is velocity that's being used. Now, again, velocity is a combination of a speed and direction. It is displacement over time. Now, remember what the displacement is, final position minus initial position. And the time really is going to be the time when we were at the final position minus the time when we were at the initial position. So PF minus PI over TF minus TI. That's the way we get the average velocity. Of course, there are instantaneous velocities as well, like when we mentioned instantaneous speeds. So it's going to be the velocity at that particular instant is going to have a speed and a direction for that particular instant. What makes it instantaneous is when we make this time here very tiny. The smaller the time, or the time difference, the more instantaneous it gets. Now, as an example, our racehorse that did run a full circle in 2 minutes. What's the average velocity of the horse? Hate to say it, but the average velocity is displacement over time. In our case, the displacement is 0. So whatever the time is, it does not matter. It's going to be 0. Now, however, in a problem like this, okay, what do they say? It's a little bit more tricky. Submarine travels at an average velocity of 20 kilometers per hour for the first 500 kilometers. 40 kilometers per hour for the next 500 kilometers. And 30 kilometers per hour for the other 500 kilometers. How long did it take the submarine to travel the first 500 kilometers? Okay, so here they didn't speak much about the direction, but the fact that it didn't change, this tells us that the direction is the same the whole time, since they didn't refer to it any other way. So even though it's not clearly expressed here, we are capable of inferring that. We are capable of deducing that. Now, how long did it take to travel the 500 kilometer? So it's a displacement of 500 kilometers. Now, what makes it a displacement is we know that the direction is all in the same direction. So we are going to say it's a plus 500 kilometers in that direction. We are going to designate the direction with a plus sign. This is my displacement. My velocity during that time is 20 kilometers per hour. Remember the expression relating displacement and velocity. So I'm solving for the time. From this equation, I have time is equal displacement over velocity. So in this particular case, that's going to be 500 kilometers over 20 kilometers per hour. The kilometers cancel out as a unit, and we get 25 hours. Quite a long time. A little bit longer than a day. Then the next question, how long did it take to travel the full distance? Okay, so what do they tell us? 40 kilometers per hour for another 500 kilometers and 30 kilometers per hour for the third 500 kilometers. Okay, so time 1, we just calculated it, 25 hours. We can calculate the time for the second segment using the same method here, or knowing that he's moving twice as fast, the time is going to be half as much, 12.5 hours. Okay, remember, again, we could have calculated it. T is equal to D over V, 500 over 40. That should give us the 12.5 hours. And then the next part is going to be 30 kilometers per hour. I'm going to use the equation here. So it's going to be 500 for T3, 500 kilometers over 30 kilometers per hour. And so I'm going to need to pull in my calculator. So that's 16.7 hours. You know, it's the average of these two numbers because 30 is halfway between them. Okay, so T3 is 16.7. So the answer to part B is the sum of all these times. So the overall time is T1 plus T2 plus T3. So in this case, it is 25 plus 12.5 plus 16.7. 54.2 hours. Okay, that's the answer to our part B. Part C, it's asking about the average velocity of the submarine. So the average velocity of the submarine for the full distance is going to be the displacement for the full distance over the time, the overall time. Now the displacement is 500 plus 500 plus 500, so it's 1500 kilometers over the full time, which we said is 54.2, I believe, hours. Okay, so again I calculate this. That gives us 27.7 kilometers per hour. Okay? Notice that the 27.7 is not really the average of these three values, the 20 plus 40 plus 30. The average of these three values is 30, not 27.7. You need to be careful with this. We don't get the average velocity by doing the average of velocities. We get it by finding the displacement and dividing the displacement by the time, like we just did here. Now there are some cases when that's going to be equal as well to the average between two velocities or three velocities. But that's not always the case. These are special cases, and we'll see them as time progresses. Let's look at another example. A car was at milepost 260 at 7 a.m. and at milepost 270 at 7:30. What is the average velocity of the car? Of course, since mileposts are in miles, we are looking for the velocity in miles per hour, let's say. Okay, so milepost 260, that means we are at position 260 miles relative to the borders, to the border of between Georgia and Florida if we are on 75. That's my initial position at T1 at 7 a.m. P final is 270 miles relative to the border again at T2. That's 7:30 a.m. So then average velocity, final position minus initial position over final time minus initial time. So that's going to be 270 miles minus 260 miles over 7:30 a.m. minus 7 a.m. So this is going to be 10 miles over 0.5 hours, 30 minutes or 0.5 hours. So it is 20 miles per hour. If we were on 75, that's a bad day.